right. So in the previous session, we got the analyzer to print all the links it has it has analyzed, and if you see, I've been running this, and it's analyzed a lot of pages from manhajuddin.com. So what we really want to do is, we want to do two things in this session. One is we want to parallelize our work, right? Add some concurrency, and we also want to show this information in a usable form, right? So, I mean, I'm the owner of manhajuddin.com, but I don't know how many broken links I have, right? Just by looking at this, I can't tell. I have to go to every page and see if there are any red check marks, and so it's cumbersome, right? It's not a straight away. It's not a good way to show this information, right? So, two things we'll get done in this session parallelly. Add some concurrency and do this, right? So let's add some concurrency first, right? So that's because that's fun. So to do that, let's go to Page Analyzer and see the places where we have a bottleneck, right? So this is very simple, right? So NQ just takes a link and adds it and spawns a new process, right? So there's nothing to be done there. Broken links for just finds the broken links, and analyze is probably where most of the work is performed. So let's see what analyze does. Analyze takes a URL, sends a request, parses the response, and then enqueues the other requests, and it also tries to find if a link is broken. So let's say a page has 100 links. Then this guy, the analyze function, visits all those 100 links and sees if they are valid, right? So now this is done sequentially, so it's going to be slow. So we should find a way to parallelize, add some concurrency here. Okay, so this is gonna be a bit tricky, but let's do this. Okay, so if you see, what we're doing here is we're finding the result of a broken link and then adding it to our ETS table. Okay, and we're getting the broken links here. So let me add those two together so that we know what's going on. And this can so yeah, so this is one chunk of code, and so this may be problematic, but let's see. What we want to do here is we want to add some parallelism, right? So we have what we have is we have a bunch of links coming from this, and we're looping through them, and we're doing two things. One, we're enqueuing things, and two, we are analyzing things, right? So let's move this part into a different loop for now. Okay, so I'm gonna say that and that, right? So this is where we are actually analyzing a link, right? Now we want to parallelize this, right? So one way to do that is do that using task dot async stream, right? So task dot async stream is a function which is new in Elixir 1.4, and what it does is it takes an enumerable, it takes a function, it takes a bunch of options, and it also, so what it does is, let's say we give task async stream a function, right? So let's get this function, which is here in there, right? And so I'm just gonna add something here. So what it does is, let's say we have 100 links on this page. It loops through each of those links, and this function, this anonymous function, is executed in a separate process once for each entry, one for each element in that enumerable, right? So if we have 100 links, this would spawn 100 processes. But task async stream also has an option which allows us to set the maximum concurrency. So I can say max concurrency is 8 because my computer has 8 cores. So and since this is an IO bound process, because we are making an HTTP request, it is very, it's a good number. The number of cores is a good number of for the number of concurrent processes. So what it's going to do now is, say it has 100 links, it's going to run 100 processes, but not all of them at the same time. It's going to run 8 processes at the most simultaneously. So it's going to take the first 8 entries, put them in, spawn one process for each entry, and let's say processes 5 and 6 are done, then it starts 2 more processes, and it just makes sure that at any point in time there are no the number of concurrent processes is not more than this number here, right? So that's good. And finally, this is a stream, so it doesn't run unless you actually use the results. So that's why we have an enum to list here. If you don't have this, this will not really happen, because it has some lazy code evaluation. Okay, so this is good, and I think this will improve our speed a lot. So let's check that out. So let me so it's still looping and fetching from ETS. Okay, so another thing, if you look at the logs here, you see it's kind of in an infinite loop where it's going to different pages, it's getting their internal links, and when it's time to add that, it already is present, right? So we haven't added a way to, so let me give you guys an example here. So let's say the first page has links to A, B, and C. So these are the 3 pages. Now page A also has links to B, C, and 0. So let's say this is the page 0, right? And page B also has links to C, A, and 0. So what's going to happen is it's going to enqueue ABC when it visits 0. And then when it visits the page A, it's going to enqueue 0 once again. And actually, the enqueue function is a bit intelligent, which because of our previous functionality, it checks if the URL has already been processed, and it just prints a message and just goes away, right? Just returns. So that's good, where we're not visiting pages which have already been visited. So that's good. But anyway, where were we? Yeah, we were adding parallelism concurrency by using task async stream, right? So let's restart our server and visit these pages once again, right? So I'm gonna say use this and add that and visit localhost 4000, and you see it seems quicker to me, but it says so it looks like it finished very fast, right? Because you see those, there are lots of debug lines there, but there is an error here. It says enumerable not implemented for OK, and this is on line number 48 on page analyzer. Let's see what that is. Line number 48 is this, and all right. So another thing about task async stream is it returns the last value, and actually let's try this out in a different script. So I'm gonna say concurrent.exs, right? So what we'll do is we'll concurrently print numbers from 1 to 10, right? So here I'll say a task async stream, and it's gonna get the element and just print it out. And maximum concurrency is, let's say, 2. And if I run this, you'll see it doesn't print anything, right? Because we need to actually use this result. So if I say enum to list, and we'll also inspect the returned value, right? So I'll say inspect label is return, right? So now if you run this, I'll see there's a syntax error on line number 5. Yeah, so now it says 1 2 3 4 5 6 7 8 9 10, and all of them have returned. So when we say .toList, it converts this into a list. Now this function from inside is not returning anything. Let's return x, okay? And if you look at the value printed here, so this is a property list with an OK tuple and 1 2 3, so the elements listed there. So what this is doing is it's creating 10 processes, passing 1 2 3 so on to those 10 processes via the anonymous function, and it's also getting the results from those 10 processes and returning it to this parent process. So it's doing all of that, and while returning, what it does is it takes the returned value and puts it in a tuple like that. If everything is good, if there is an error, it probably throws an error. But if it went fine, if the process exited normally, it would return something of this shape. Okay, so why are we looking at that? Because here enum.toList is failing. Why is it failing? We have an async stream where we are parsing links. We're looping over. Oh, so here if you see, we are looping over these so what we want to do is we want to loop over these links twice, right? So we can't do that. So I'll say links is, and we will do an enum.each once, and we'll also do a task async stream once. Okay, so we are enqueuing the links, and we are also finding the broken links on this page. Okay, so that's good. Let's restart this. And it's currently empty because our ETS table was just started. And now if you go back to home, you see there are all these pages here, right? And so it is running parallelly, I assume. And if you see, it's checking a lot of links, and it's all happening very quickly, right? So all right, anyway, so we parallelized our code. That's a good thing, and we did it with very little effort. So I'm gonna add a commit here. So parallelize. All right. Now the final thing we're going to do here is show the info in a usable form, right? So right now this information is not very usable. So what I would like to do here is when you add code.webserver.in, right, it should take me to a page which lists all the internal links and also the broken links for those internal links on this same page, right? So let's see. So we'll probably have to do some refactoring here. Um, so let's think through this process, right? So if let me open up the page analyzer here. So at the moment, the shape of our page analyzer data is it has a URLs ETS table where the key is a URL and the list is and the value is a list of tuples, right? Key value pairs, where the key is another URL and the boolean and the value is a boolean, which tells us if it's a broken link or not, right? So here, what we need to do is we need to store a hierarchical, information in a hierarchical fashion, where we say, let's say, URLs has a URL, and so this is going to be the root URL, the starting URL, and it's going to have a list of internal pages, right? So internal links, right? So it's going to have internal links, and so maybe link 1, right? And it's also going to have a list of broken links on that internal page, okay? And what do we do if you want to enqueue something? So it's not very straightforward. So we need to come up with a good way to structure this. Or let's see if we can do this without restructuring our code, right? So it's definitely possible. We already have code, we already have all the information, right? So this is the starting URL, and these are the other internal URLs or external URL, right? So this is just URL, right? So let's get into IEX, and here if I say ETS dot table to list URLs, we'll see we have a whole list of things, right? Now what we can do is obviously this is not the best way to do this, but let's try it out. So I'm gonna go to the analyze page. So go to page analyzer, right? And here I'm going to add a function here called analysis or result for URL, okay? And what it's going to do is it's going to take that URL, right, and find the host of that URL. So host is URI.parse URL.host, right? And what it's going to do is it's going to get all the links, and it's going to filter those where the link host is the same as this host, right? So this gives me all the links associated with that URL, right? And now we're going to shape it properly. So now we have a bunch of links and we want to shape this properly. So what we'll do is we'll say link right? So this link is actually an href, so it's a string here, right? So link to href, just to convey that it's actually an href. And what we want to do here is, so the result for is going to return a shape which looks like this. It's going to return a list of links and the broken links. And actually let's make it a proper map. So I'll say link is link and broken links is a list, and it's also going to have a count of broken links. Well, yeah, yeah. So that's so let's see. So what we have here is we have an href. I'm gonna say, and let me warn you that this is highly inefficient, right? Because we are looping over the same thing again and again, and we don't have the data in the right shape. But let's just get this working first, right? So ets dot lookup href is going to give us two things. It's going to give us the href, which we're going to ignore, and it's also going to give us all the links, right? So all the links. And what we want to do here is we want to return a map, which is linkage href, right? Or I'll call it href is href. And the key, all right, so the href is href, and we also want the broken links. So broken links is all links, uh, but filtered so that the link and broken, we don't care about the link. Broken is true, right? So broken should be true. So we're getting all those broken links, and let me get rid of the count here because I think we don't need that. Right? So result for URL is going to give us this. So let's test this out in the console. Let me recompile, and we'll say page alias broken links dot page analyzer, and page analyzer dot analysis for, or what is that, result for code, no, code dot web server dot in, and it says lookup 2 is not defined. So yeah, we forgot the name of the ETS table. So let's recompile, and yeah, so this gives us href better throttler, and all the broken links are empty here, so which means there are no broken links, right? So which is good, and what we want to do is we want to take this information and show it in a nice way. So we need to go back to the page controller, and here we enqueue it, and instead of using broken links, I'll say result for result, and if you look at the shape of this, let's call it links, right? So links is links, and analyze HTML. It's going to have for links, and each link as a map, right? And that map has an href and broken links array. I'm sorry, broken links list, right? So we've got that, and what we want to do here is we want to say the href is that, and so all right, let's see. So since we have just the broken links to show here, we have a list, and let me delete that and say we have href here, right? Let me just do an inspect just to avoid any other, any of those failures if it's not a string. And we also want to show a count, right? So I'll say number of broken links is length of broken links, okay? And for now, I think this is enough. let's recompile and reload this. And if you see, it says uh, number of broken links is 0, 0, 0, 0, 0, 0, right? So we could also make it so that uh, can have pages with broken links and pages without broken links, right? And what we can do here is let's say href, and we don't care about broken links here because we don't have any. And this would be a filtered list. So I'll say enum filter links and try to find them where let me take another look at the shape of that data. And where is that? Yeah, so we have href and broken links, so it's just a map, right? So yeah, it's a map. And I'll say broken links is broken links, and I'll say length of broken links is equal to 0, right? So those are the pages without any broken links. And there's something wrong here. It says undefined function broken links. Hmm. What? Yeah. So these are the pages without broken links. Nice. And the pages with broken links is going to be an inverse of this, right? Where length is greater than 0, and we'll also show the broken links. And we also match on that. So let's say broken links is broken links, right? So what's going on here? Yeah, so pages without broken links, 0. That's nice. And we can actually do one better and do this in the controller itself. Page controller. In the controller, we can filter the links and say enum filter. And instead of enum filter, we can use split width. And so I'll say links is that, and we'll split links by the number of broken links. So if it is 0, it means these are good pages, right? And then we have bad pages, right? And that's what split width does, right? So let's do a quick check. Split, and if I say 1 to 10, enum split width x mod 2 is 0, and we do an IO inspect here, and an expected token end. So we have 1 to 10, that I don't know what I'm doing wrong here. So x enum split width x mod 2 is 0. Is that yeah, so I think there's no mod in Elixir, so I'll say a reminder of x by 2 is 0. That's good. So this gives us a tuple with 2 elements, one where the value is truthy, one where the value is falsy, and that gives us good links and bad links and actually broken links, right? So we'll say links is good links is good links, and broken links is broken links, right? And if we go back here, we don't have to do the filtering again. So I'll say get rid of that, um, get rid of all of that, and this is uh, good links, and this is the broken links collection, right? So awesome, and we can also show the count here. So I'll say um, number. All right. So here I will say length of broken links, and I'll also put a number here. Length of good links, and we'll put this in a parenthesis, show that it's a number, right? So pages with broken link 0, pages without broken link 60. Awesome. All right, so we're almost done. Let me analyze my blog here, see how many broken links I have on my blog, and wow, so that's a lot of pages, and you see it's crawling those many pages. Okay, nice, nice. Hmm. So this is weird. It's increasing the pages with broken links and it's decreasing them again for some reason. So it should just be increasing. So anyway, I'll take a look at that, and let's see. It says this is a broken link. So let me just go there, see if it really is a broken link. It's not a broken link. Not sure why. So anyway, there may be a bug in our code, and or maybe it's doing too many requests um, at the same time, and it's let's look at the logs, right? So the logs will tell us what's going on, and so here we see it says SSL handshake failed. So it's failing because it's trying to get the HTTPS version, is it? And let me just make a quick check here. SSL handshake failed for this. Yeah, so it's failing for the. I'm not sure. So anyway, there may be a bug in our code, but we made a lot of good progress. Okay, so I'll stop the session here. I'll stop the screencast here, and we'll look at adding more features to this in the next session. All right. So goodbye and have a great day. Awesome.